Hello, Math 2. This is Mrs. Bricky, and this is our second lesson on solving systems. Today we're going to be focusing on graphs. So a graph of an equation is just a record of all of the solutions to that equation. So we have an equation y minus 2x is equal to negative 4. So we just want to think about what the y value will be for each of these x values. So if x is negative 2, we have y plus 4 is equal to negative 4. So that means the y value is negative 8. If x is negative 1, we have y plus 2 is equal to negative 4. That means that x value is negative 6. If x is 0, we have y plus 0 is equal to negative 4. So that means y is equal to negative 4. If x is equal to 1, we have y minus 2 is equal to negative 4. That means the y value is negative 2. And then finally, if x is 2, we have y minus 4 is equal to negative 4, but that means the y value has to be 0. So we have this relationship, y minus 2x is equal to negative 4, and for any x value, we can find the y value that goes with us. And all of these are solutions to this equation. If we looked at a graph of this, each of these ordered pairs is 1 point, negative 2, negative 8. Sorry, that was my bad. Negative 1, negative 6. 0 as an x value goes with the y value of negative 4. 1 goes with negative 2, and 2, 0. And so you can see that there's sort of a pattern here. And, we could find some other ordered pairs. Wow, that is not the straightest line I've ever drawn. Just by looking at this graph, we could name more coordinate pairs that would make this equation true. For example, 3, 2. And if I could draw a straight line, we would have, 4 goes with 4. And the x value 5 goes with 6, etc. Okay, so we've been working with systems of equations. So what happens if we graph both of the equations in a system of equations? What part of the graph would be the solution to the system? Well, we are going to graph these two equations. These are, I hope you recognize them as lines. Lines are often in the form slope multiplied by x plus the y-intercept. Y equals mx plus b is a really common form for a line. So for our first line, our y-intercept is 1, and our slope is negative 1. The slope is the number in front of x. So we're going to go down 1 over 1 to create that line. It's really hard on my tablet to draw a straight line, so I am going to use a straight line tool because I can, and because I'm so bad at drawing straight lines on a tablet. Okay, so there's our first equation, our first graph. And then our second graph, y equals 2x minus 8. This has a y-intercept of negative 8 and a slope of 2. So we're going to start at negative 8. Slope 2 means that we're going up 2 over 1, up 2 over 1 to create that graph. And again, I'm going to use my tool because I am not great at drawing these straight lines. Okay, so we want to find the solution to this system, and the system is a coordinate pair x, y that is true for both of these equations. So what you might notice is that they have one intersection point, and this is a point where that ordered pair, which is 3, -2, that ordered pair works in both of these equations, right? It's on the blue line, it's on the green line. So what we're looking for when we solve systems of equations graphically is we're looking for an intersection. We're looking for where do they cross. Okay, so here's another system. We're going to find where these two intersect. The first equation that we want to graph is y is equal to 7. Well, here's y is equal to 7 right here. But all of these points have a y value of 7. So y equals 7 is a horizontal line where on that horizontal line, every single y value is 7. So if you see something like y is equal to a number, that's a horizontal line. I'm not sure if it's going to horizontal. I can't spell. If you see an equation that's like x equals a number, that would be vertical, because we would be looking for all of the points that have an x value of 5. So that would be a vertical line at x equals 5. I'm not sure if vertical comes up. I can't recall, but if it does, now you know. All right, so our second line, y equals -2x minus 5. The y-intercept is -5. So starting down here, and the slope of this is -2. So we're going to count down 2 over 1. If you have a situation like this where it kind of goes off the graph, you just kind of do that pattern backwards. So I'm going up 2 and back 1. And you can probably see where that intersection point is happening. I'll try freehanding this one. Oh, it's so bad. Okay. Well, I don't know why it makes it so wiggly. All right, so we're looking for the intersection point, and it is right here. So our solution to this system is -6, 7. So our x value is -6, and our y coordinate is 7. And we kind of knew that y coordinate was going to be 7 from the get-go, because one of our equations was that the y has to be 7. Also, this system would probably be pretty easy to solve by substitution. Okay, if you want to try this one on your own, you can pause the video and give it a shot. I'll put the solution up. So we've got y is equal to 3x minus 4. So y-intercept -4, slope is 3. So we're going up 3 over 1. And that looks like this. Our other line is -2/3 x plus 7. So we start at the y-intercept 7. We're going down 2 over 3. Oh, we see our solution now. I'm going to go ahead and finish graphing the line. And our solution to the system is 3, 5. It is possible for systems to have no solution. So let's see what that looks like. I'm going to go ahead and add the 2 to the other side. So we've got 3/4 x plus 2. So up 3 over 4. And our second line, 3/4 x plus 4. So that's starting here, up 3 over 4. And get enough points that you can get that line graphed nicely. And please, on your practice problems, graph the lines. Sometimes people just like to put dots, and it's easy to lose track of what's happening, so do try to graph your lines. These two lines are parallel. There is no intersection. Now, sometimes the intersection might just be off your coordinate plane, so you want to watch for cases like that. But these two lines have the same slope. They are never going to intersect, even if I had a larger viewing window on my coordinate plane. So no intersection. And what no intersection means? It means that this system has no solution. Okay, here is a system with infinite solutions. So let's graph it and see what it looks like when a system has infinite solutions. Our first equation is y equals negative 2x plus 4. So we start at 4 for the y-intercept, and we're doing a negative 2 slope. And the second equation, the second equation doesn't have the y isolated, so I'm going to go ahead and solve it for y. 2y is equal to negative 4x plus 8. Dividing by 2 gives me negative 4 over 2x plus 8 over 2, just dividing both terms by 2. And that is y is equal to negative 2x plus 4. That's the same line. Like, it starts at 4 and it has a slope of negative 2. So every point that's on the blue line is also a point on the green line. So this is a case, the two lines are the same. The two graphs are the same. So this is a case of infinite solutions. And again, that doesn't mean every point is a solution. This point is not a solution. This point is not a solution. It just means I can find an infinite number of xy pairs that are solutions to the system, because every single point on that line is a solution. Okay, you can maybe pause the video, work on some problems if you want, and then continue the video, or you can just keep going on the video. Okay, in Math 2, we have learned to graph several types of functions and equations. For example, if we have x squared plus y plus 1 squared is equal to 25, I hope you recognize that that is a circle. Or if you have y is equal to the absolute value of x minus 4 minus 3, I hope you recognize that as a V shape. And y is equal to negative 2x squared minus 4 with that power 2 on the x, but the y is regular. That's a parabola, a U shape or a parabola. So a system might include any of these types of equations. So to solve the system, we are still looking for intersection points, but with nonlinear shapes. If we have circles or V's or U's, we can have multiple solutions. Okay, so here's our first quadratic system that we're going to graph. So we have y is equal to x minus 3 squared minus 1, and we have y is equal to x plus 2 squared minus 6. So these are both parabolas. We know that they're parabolas because of the form of the function. In particular, the fact that we have these powers of 2 are telling us that these are parabola U shapes. So the first one, the vertex, is going to be at 3, negative 1. So our x value is 3. That makes this 0. And then negative 1 is the y value. So 3, negative 1 is right here. And then this parabola just has our usual stretch 1. For a parabola, that's going to be following a 1, 3, 5 pattern. So this is going to go from this vertex up 1 over 1, up 3 over 1, and up 5 over 1. And so we've got this parabola. And then our second parabola has a vertex at negative 2, negative 6. So the x value that makes this 0 is negative 2. So negative 2, negative 6 is the vertex. Negative 2, negative 6, all the way down here. So again, this has a stretch of 1. So our pattern is going to be 1, 3, 5. So up 1 over 1, up 3 over 1, up 5 over 1. Okay, so here's our second parabola. Sorry, I'm not really great at drawing graphs on my tablet. I do better on the board. Okay, so we've got our two parabolas. We were looking for their intersection point. And so you can see that our system's solution is, it's right here at this point, 1, 3. Now this system is probably easier to solve by graphing than it would be algebraically. So sometimes there are systems that it would be the easiest method would be by graphing, and sometimes the easiest method is by algebra. So, if it doesn't tell you a particular way that you're supposed to solve it, you could always just choose which one you think would be easier. Okay, so this is another system that has two parabolas. Our first parabola has a vertex at -2, 6. Now this parabola has a negative at the beginning. That's like a -1. So the 1, 3, 5 pattern is multiplied by -1 for this parabola. It's going to be -1, -3, -5, which just means that the parabola is opening downward instead of upward. So down 1, over 1, down 3, down 5 as we go over 1. And it is symmetric, so we have that on both directions. So here's our parabola. The second parabola, sometimes people get stuck on this one because it doesn't have the parentheses. It sort of doesn't look the same way the one above looks. If we wrote it in the same form as the other one, it might look something like this. But when we aren't adding or subtracting a number from the x, it just sort of becomes x squared. Anyway, so this one has a vertex at 0, -4 right here. And the stretch of this is just 1, so it's going to go up 1 over 1, up 3 over 1, up 5 over 1 from that vertex at 0, -4. And so this one actually ends up having two solutions. The two parabolas intersect twice. They intersect right here at -3, +5 as one solution, and the other solution is 1, -3. So two solutions there. Okay, here is another system. We want to solve this system by graphing. So our first graph shape, we have absolute value bars, so that's going to be a V shape. And the vertex of this V shape is at +3, -6. So the x value that makes a 0 here is +3, -6. 3, -6 is right here. And then for a V shape, we need to know a slope. And this one has that base slope of 1. So we're going to go up 1 over 1 to make one side of the V, and then up 1 and back 1 to make the other side of the V. When you're graphing up an absolute value function, just make sure that you don't accidentally do a line. That's probably one of the common errors. Okay, and then the second shape that we're graphing, we have our x with a -3, and that's squared, and we have plus y plus 1 squared. This is a circle. The center of the circle is at +3, -1. And then the radius of the circle, remember that the radius of the circle comes from this number, but this is not the radius. This is the radius squared. So when we square the radius of the circle, we get 25. That means the radius itself is 5. So we're putting our center at 3, -1, and we're going to count out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. So our circle, I'm going to use the tool because it's so hard to draw shapes. Our circle looks like this. And you can see that we do have 3 solutions in this case. We've got this one, and then we also have this one at the bottom. It doesn't cross the circle, but it does touch the circle, so that does count as a solution. So there are 3 solutions to this system. They are -2, -1, 3, -6, and 8, -1. Okay, so we can solve a system of equations by graphing the equation. These are just our big ideas for today. And the solution to the system is the points where the graph intersects. Also recalling that we can have multiple solutions if there are multiple intersection points. And then it is possible to have infinite solutions if the 2 graphs coincide. And it is also possible to have no solution if the 2 graphs never intersect. No solution is also an infinite solution is also possible with parabolas and other shapes. Those are not limited to lines. For example, if we had these 2 parabolas, that would be a no solution situation because they never cross. Let me or your teacher know if you have any questions, and try out some of those practice problems on your own. Thank you.